Okay, so in this video, we will solve problem 9F from problem sheet number 5. If you recall, the setup is that out of a regular deck of 52 cards, we are dealt at random 5 cards, and we want to count the total number of possible hands that consist of 3 of a kind only. This means a triple and nothing stronger, so we are ruling out a triple and a pair. So a triple and then 2 distinct cards from each other and from the triple. So if you recall in total, again here because we have a setup that is unordered and without replacement, since there are 52 cards in total, 4 suits, 13 different kinds for each suit, 52 cards in total, and we are choosing 5 at random in an unordered and without replacement fashion, there are in total 52 choose 5 different possible hands of 5 cards, which is about 2.6 million different possible such hands. And out of those roughly 2.6 million hands of 5 cards, we want to count those that consist of 3 of a kind only. So a triple and nothing stronger, so no triple and a pair. Triple and 2 distinct cards. As always, we start with an example of such a hand, and then we will build from the example to the general counting problem. So we will arrange the cards with the triple first, then the 2 remaining cards. So a triple of what, right? It could be a triple of aces, kings, queens, up to 2s. Say we have a triple of kings. Well, that's not complete, right? Which of the 3 kings did we choose? There were 4 possibilities. Say we have the king of hearts, then diamonds, then spades. So we now have our triple. We're left with the 2 remaining cards. Again, because we want a triple and nothing stronger. The 4th card can be a king, so the kings are ruled out. Could be any other card. Say it's an ace. Again, which ace? There are 4 possible different suits. Say it's the ace of diamonds. And the 5th card can't be an ace. This would give us a pair and a triple. We don't want that. And it can't be a king because it would be a quadruple and an ace. And we only want a triple and nothing stronger. So the 5th card can't be a king nor an ace. So the aces and kings are ruled out. Any other card fits the bill. Say it's a 10. Again, that's not complete. Which of the 4 tens? Let's pick one at random. Say it's the 10 of clubs. So now we have an actual example of a hand of 5 cards that consists of a triple only. So 3 of a kind, a triple, and nothing stronger. So 2 distinct cards from each other and from the kind of our triple. Let's now build from this example to counting all possible such hands of 5 cards. So first we chose the triple, right? We chose the kind. Do we have a triple of aces, kings, queens, jacks, up to 2s? So we're choosing first the kind. Out of the 13 available kinds, we chose 1 kind for the triple. So that's 13, choose 1. But that's not complete. That's only the kind. So say we've chosen kings. Okay. Well, how many possible triples of kings can we create, right? Well, out of the 4 available kings, we chose 3. So and 4, choose 3. The total number of possible triples of kings, given that there are 4 kings to choose from. Now we have counted all possible triples. But that's not all. we have an incomplete counting here. We're missing the number of possibilities for the remaining 2 cards. And here we have to be careful, right? We first again chose the kind, but we no longer have 13 kinds to choose from, as the kinds of the last 2 cards cannot be the same as the kind of the triple. So whereas we had initially 13 kinds to choose from, we have to rule out the first kind that we chose, and so now we're down to 12 kinds to choose from. And out of the 12 kinds left over, after we rule out the kind of our triple, how many different kinds do we choose? 2, right? Because the kind of the 4th card and the kind of the 5th card have to be distinct. If they were the same, this would be a pair and a triple, a stronger hand. We don't want to allow stronger hands, because these must be of a different kind. Again, it is a setup without replacement, so we use our combination. So out of 12 kinds left over, we choose 2 distinct kinds. But this is yet incomplete, right? Now we say the 4th card is an ace, and the 5th card is a 10. Well, how many possibilities do we have for the ace? Well, there are 4 aces to choose from, and we chose 1. So there were 4 possibilities for the ace. Of course, you can write only 4, or 4 choose 1, as 4 choose 1 is the same as 4. And we also have to count the number of possibilities for the 10. Again, out of the 4 available 10s, we only chose 1. So there were 4 possibilities for the 10, for the 5th card. Again, you can write 4 or 4 choose 1, same thing. And now we have a complete answer. We chose the kind of the first triple, well, the only triple. We chose the kind of our triple. Out of the 4 available cards, we chose 3 of them. So total number of ways here of choosing the triple. Then, out of the remaining 12 kinds to choose from, we chose 2 distinct kinds. And for each card, for each kind, aces and 10s, there are 4 possibilities for the 4th card. 4 choose 1 is 4. And there are 4 possibilities to choose from for the 5th card. 4 choose 1 again is 4. We can simplify. 13 choose 1 is 13. 4 choose 3. 12 choose 2. Again, 4c1 is 4. So this is 4 times 4, 4 squared. And if you now use your calculator, you will find exactly 54,912. So you can see out of 2,598,960 different possible hands of 5 cards, exactly 44,912 of those consist of a triple and nothing stronger.